Neetcode 150, 3-sum. I strongly recommend you to do the problem 2-sum part 2 prior to solving 3-sum. So in this problem, we want to return 3 numbers in our array of integers that adds up to 0. So for example, here, if I look at the array, I see that -3 plus -1, well, -3 plus 0 plus 3 will return 0. So this is a combo of 3 numbers in our arrays that adds up to 0. This is something we want to return. If we keep looking, we see -2, 0, 2. This is another trio that we want to have. We have -1, 0, 1. Another trio will be -3, 1, and 2. Okay, so you get the concepts. Now, how can you solve this problem? So if you remember the 2-sum problem, we received a target and you had to find 2 numbers and add up to this target. And the best solution to solve this problem was to use a two-pointer technique. So for example, if my target is 3, well, I will go for I will have a pointer to the left and a pointer to the right, here, and I will add both numbers. And if they are equal to the target, we will render them. If their sum is greater than the target, we will shift our right pointer to the left. Otherwise, we will shift our left pointer to the right. Okay, so this is basically what we're gonna use, and we're gonna also set our own target. So we're gonna start with the index 0, -3, and basically we want to have a target of 3 in this case. So we're gonna go put our left pointer to the right neighbor of 3, and our basically our right end pointer to the last index. And we're gonna use the 2-pointer technique to find 2 numbers that adds up to 3. So here, if we add -2 and 3, we have 1. 1 is smaller than 3. So we are gonna add 1 to the left pointer. Now we have -1 and 3, which adds up to 2. It is still smaller, so we add 1 to the left pointer. We add 0 and 3. All right, so this adds up to 3. Hence, we can confidently return this index 0, index 3, and index 6. These adds up to 0. So let's go ahead and code this. So we will want to first create our array that is going to return the trios. So we can call it output. Okay. And one thing that we want to do is to sort first the array. Okay. We are given the constraint of doing this in a time complexity of big O of n squared, and sorting is basically n log n of time complexity. So we can permit ourselves to first sort the array. This is going to make the work so easier, and it's going to allow us to use the 2-pointer technique. So what I'm going to do is I'm going to use the Python method nums.sort. There you go. Now we have a sorted array, and we want to now go through every numbers and also get the index of the numbers. We can do so by saying it for I and A in enumerate nums. So this is how you get the index and the value of every position in your array. First, we can use our own logic here and think of what does it mean if the number is positive, right? We have a sorted array and we have a positive number. That means that all the numbers to its right are going to be positive as well. So if we end up having an array of only positive numbers, we know that there is no trio that is going to give us a result of 0. So a first check we have to do is if the value of that number is greater than 0. We're going to break the for loop. And we also have to check if the number at this current index is the same number as the previous one. Because otherwise, if you have, for example, I will just delete this. If I have another -3 here, and I first find my my 3 O's using the tree at index 0, and then I go inside my second loop of my for loop, and I use this -3 as well, well, I'm going to receive a duplicate, right? Because we're going to also use the 2-pointer technique, and we're going to end up finding our -303 or -3 1 2. So to avoid this, because it explicitly say that you must you should not, your output shall not contain any duplicates. So first you want to check if the index is greater than 0, because at index 0 you cannot have already a duplicate. So if the index is greater than 0, and nums, and also a is the same as the number just before its number. So these are the two cases where we want to continue. So at index 0, you don't want to go through the 2-pointer technique. You want to keep going. And also, if the previous number is the exact same one as the current number, you also want to continue your loop. And this is the point where we're going to add our left and our right pointer. So we're going to set our left, right pointer. And you've probably guessed it, the left pointer, it's going to be the index of the current number plus 1. And the right pointer is going to be the end of the array. So we're going to take the length of the nums -1. Okay. And now this is the exact same solution as the 2-pointer, the 2-sum problem. So if you solve this problem before, you'll see it's pretty straightforward. All right, so while the left pointer is smaller than the right one, our addition, it's going to be equal to the value we are currently at, a, plus the value of the array nums at the index of the left pointer, and the value of the array nums at the index of the right pointer. Okay? If the addition is greater than 0, what do we do in this case? Well, we're going to have to shift our right pointer to the left. Okay. The other case is if the addition is smaller than 0. In this case, you want to move our left pointer to the right. Okay. And if the first two statements are false, it means that the addition is actually equal to 0, in which case you want to basically append to I call it output. So we're going to append to our output. What do we want to happen? We want to add the trio, starting with A, with nums index left and nums at the index right. Okay. And after this, once we found one solution, we will want to keep looping through basically what is inside the left and the right pointer to see if there is another trio that can be made with the number A of nums. So we're gonna shift our left pointer by one to the right, and we're gonna shift our right pointer by one to the left. Okay. And basically after this, we're gonna loop again in by using the 2-pointer technique. But we also have to check if within that while loop, we have to check if the number at the index L. Okay, so we're gonna use a while loop. So if the value of the array nums at the index left is the same as its neighbor to the left, well, it means that we might actually gonna get the same error with the duplicates. So we want to add, we want to shift our left pointer again to the right. And there is also one thing that I forgot, is that we have to ensure that the left pointer is always smaller than the right pointer. Okay? So this is how we solve this problem. Don't forget to render, to return the output. Okay. And this is it. Oh. Excuse me. We're gonna have to do some debugging. Okay. I wrote a single equal. I apologize for this. And there you go. We got the right answer. So I hope you found this tutorial helpful, and I hope to see you in the next one.